Assalamualaikum and good day everyone. My name is Dr. Najihah Muhammad. I will do the explanation for the new topic homogeneous equation from chapter 1. Okay, here are the topics from chapter 1. I believe that everybody know what is the basic definition and terminologies in the chapter. And then everyone should know by now the direct integration as well as the separable equations. And then here we will do the discussion for the next method, which is homogeneous equations. Okay, first thing maybe I do explain about the expected outcome. Okay, first thing you have to know how to identify the type of the first order or ODE for homogeneous equation. Is it okay? Is it suitable to choose the method? And then next one, find the solution for the first order ODE by using the method. Okay, so now before we go to the step of the method, we should know how to identify whether or not the given equation is homogeneous. Okay, we start by the differential equation, which is dy dx, we assume as f of xy. F of xy can be any function involving these two variables, which is x and y. It is called homogeneous equation if f of lambda x, lambda y equals to f xy for every real value of lambda. Okay, so now we go to the example. Okay, identify whether the following is an homogeneous differential equation. We go to the first first differential equation, which is dy per dx equals to y minus x divided by y plus x. Okay, first thing, you have to equate the function equals to fxy. Okay, and then you have to find what is the f lambda x lambda y by replacing the x by lambda x and replacing the y by lambda y. So then we will have this one. Okay, next step, you have to simplify the functions, the equation. Okay, we can see that this one to the numerator as well as denominator, we can factorize out the lambda, isn't it? Okay, and then here obviously we can cancel out the lambda. So then we will have back y minus x per y plus x, which is, it goes back to fxy. Alright, so obviously the first equation will be homogeneous. Alright, so then we go to the second one, B. Okay, so first thing, dy per dx equals to x squared y plus y squared. Then we equate that one equals to fxy. Then we replace the x by lambda x, y by lambda y, and then we will have this one. And then obviously, we cannot do anything right to cancel out the lambda. It will remain until the end. So obviously, this one is not homogeneous. Not homogeneous meaning we cannot proceed with the method. You have to check other method. Okay, so now we go to the step, which include the method. Solving homogeneous equation. Okay, in practice, homogeneous equation can be reduced to separable equation using the substitution. Okay, the main idea is the homogeneous equation, once we have identified that one homogeneous, we have to reduce it to separable equation. Okay, this one is standard. Okay, meaning this one is standard. Okay, y equals to Vx is a standard. When we know that one is homogeneous equation, so then you have to use this one. You have to use this one. Okay, so next step, you have to differentiate the variable, all the variable with respect to x. Okay, the y will become dy dx, and then for the v and the x, you should use product rule. Okay, remember product rule, when you have uv when you want to differentiate uv with respect to x, you will have uv prime plus vu prime, isn't it? Okay, so here we will have we copy the v. Okay, we copy the v, become v, and then we differentiate x. We differentiate x with respect to x, we will have 1, isn't it? Okay, I copy over here. Okay, we copy the v, and then we do the differentiation of x with respect to x, and then plus, we differentiate the v, and then we copy the x, and then maybe we simplify it, become v plus x dv dx, right? So it will become equation number 2. Okay, then next step, okay, we go to step by step. So now we have step number 1, make sure that the given equation is homogeneous, done. Step number 2, substitute equation 1 and equation 2 into the original equation. Okay, what is 1 and 2? This is 1, which is this one, y equals to vx, and then equation number 2, which is the differentiation of this set. Okay, so we substitute these two into the question. Okay, and then step number 3, separate the variable x and v in the resulting equation. Okay, I want to explain a bit about step number 2. Actually, the main idea, we want to eliminate the variable y, so then we just have v and x only. Okay, so step number 4, integrate both sides of the dE with respect to the related variables. Okay, meaning we do the separation, right and left, and then we integrate both sides, and then substitute back, which is coming from equation number 1, v equals to y divided by x, to obtain the general solution, meaning the original equation is in y and x, isn't it? So we have to replace it back because we don't want that v. Okay, done. Right, so we will discuss the first question by using homogeneous equation. Okay, first thing we have to check, is it this one, this differential equation is homogeneous or not? Okay, remember that first step, we have to equate the dy dx equals to fxy, which is the meaning of fxy equals to xy per x squared plus y squared. Okay, next step, we have to create this one, lambda x lambda y, meaning the x become lambda x, the y become lambda y, divided by x squared lambda x in bracket squared plus lambda y in bracket squared. Okay, over here you have to expand and simplify. Okay, we will expand, we will have x squared, lambda squared xy divided by lambda squared x squared plus lambda squared y squared. Okay, so we simplify out or factorize out the lambda squared. As I can see, we have lambda squared, right, for the numerator as well as denominator. Okay, so we can cancel out the lambda squared over here. So obviously we have fxy back, right, isn't it? So thus this one is homogeneous. Okay, so clearly we can use the homogeneous method. So to solve this equation, I copy this one to here. Alright, so now we will do the step. Okay, remember that we use the substitution equation. This one is standard. Y equals to Vx. And then the second one, we have to differentiate the equation number 1 with respect to x. It will become dy per dx equals to v plus x dv dx. Okay, So now, this is equation number 2. Next step, we have to substitute equation 1 and equation 2 into the question lah. Okay, maybe I label this one as A. The A, right? 1 and 2 into the A. Okay, so if you see over here, dy over dx, right? We will replace by equation number 2. So, we will have v plus x dv dx equals to, and then we have y become vx, okay, and then x squared will remain, plus y squared become vx squared. Okay, so now simplify, expand and simplify as usual. Vx squared, x squared plus v squared x squared. Okay, if you notice over here, they are sharing x squared for all the term, right? So we factorize out this one. V1 plus v squared. Okay, so obviously we can cut the x squared. So we will have v plus x dv dx over here. Okay, I will copy back this one. V plus x dv dx equals to v1 plus v squared. Okay, so I believe everybody know what to do next. You have to simplify, and because we want to do the separation. At this level, actually we do separable equation punya step lah. Okay, so first thing we move the v first. Minus v, right? Then we merge this one, become v minus v times 1 plus v squared. 1 plus v squared. Okay, expand v minus v minus v cube. Okay, be careful. 1 plus v squared. Then we simplify, minus v cube per 1 plus v squared. Okay, if you at this point we can do the separation. 1 plus v squared per v cube dv equals to, okay, I leave the negative notation at the right side, minus 1 per x dx. Okay, I put integration sign for both sides. So now clearly we have separate the v with the dv, the x with the dx. Okay, so we will do the next process. I paste this one at the new page. Okay, we will start this integrate both sides. Okay, first thing, maybe we change the form first. 1 divided by v cube plus v squared per v cube dv. Okay, clearly over here is a straightforward ln x plus c, and then we have to adjust all the term at the left side. This will become v power negative 3, this will become 1 per v dv, and this one will be remain. Okay, and then v power negative 3, we will have v power negative 2 divided by negative 2 plus ln v equals to negative ln x plus c. Okay, simplify this one. 1 per 2v squared plus ln v plus ln x equals to c. we have to simplify this one. I can see that we can merge the ln 1 per 2 v squared plus ln vx equals to c. Okay, so now so remember that we have y equals to vx. I can see that we can start to replace the variable back. So obviously v equals to y per x. So we replace this equation into this one. We label it as 3. Okay, this will become negative 1 per 2 y per x squared plus ln y per x times x equals to c. Okay, then we simplify this one, become 1 per 2 y squared per x squared. We have to manipulate, this will become x squared over here plus ln y. Yes, okay. So ln y equals to c minus plus x squared per 2y squared. Okay, so we use the properties. Y equals to exponent c plus x squared per 2y squared. We simplify this one, a exponent x squared per 2y squared. Okay, which is the a equals to exponent c. So this is the answer. I highlight this one. So this is our answer for this question. Okay, so this is actually the solution that I've typed before. Okay, it's just similar like mine above. Okay, so you can do exercise from this exercise 1.5. First thing, the first question, you have to check whether or not homogeneous, and then if homogeneous, you have to proceed with the method, and then this one, find the particular. Okay, I hope you can do a lot of practice, because if you do not do the exercise, you do not facing the challenge, so you don't know how to do it. Okay, so good luck everybody.